All right, so section 2, chapter 5, we're gonna start to look at some integration log rules for integration, and let's revisit really quickly because the last section we focused a lot on the derivative of ln, and the idea was, look, the derivative of ln of u is just u prime over u. Now, of course, the derivative of ln of x is just what? It's just 1 over x. But you could still use u prime over u. It would be the same. Now, in this case, let's say if that being said, if we want to start thinking about, since this is our derivative, if we want to start thinking about the integration of u prime over u. Now, of course, u and u prime are in terms of x, right? Because you always substitute back in. But so if you wanted to integrate that with respect to, I'll go ahead and say, yeah, with respect to x, what would you get back out, right? Just think about what I'm saying. If I give you ln of u, as of if you watched the last videos, then you're going to be okay to take that derivative. You're just going to do u prime over u. But what if you want to go backwards, right? You want to integrate u prime over u. Well, then, of course, what you're going to get is ln of u. All right, now, with that in mind, let's practice a couple really quickly. We'll go through these as quick as we can. So let's start with, if you want to integrate 2 over x with respect to x. I'm fine integrating it the way it sets. I think that you'll find life is a little bit easier if you bring that constant out in front of that integral, right? You can always, that constant multiple rule, you can always bring that 2 out front. And then this is an easy integral, right? Think about it. The integral of 1 over x is just ln of x, because the derivative of ln x is 1 over x. So we end up with 2 times the ln of x. And then what am I missing right here? We are now integrating, so we have to have plus c. All right. That is the correct, that is absolutely the integral. That is correct. Normally what you'll see if you were to look this up in the back of the, say, your textbook, they normally would go a little bit farther and bring that 2 back in, right? Remember those log properties that allow you to bring the 2 out front? They normally would go and write that as ln of x squared, right? I'll go ahead and do something really quickly. So ln of x squared and that would be plus c. So the idea is they normally you're going to use absolute value symbols when you take when you are around your ln, because you're how do I express this? You can think about if you just had 2 over x. There's no stipulations of that x can't be negative numbers, right? You could plug in as the only thing x cannot be is 0 in that case. But when you integrate 2 over x, with that answer ln of x, remember what I said, you cannot plug in negative values inside of your integral. So they normally, and you can try it, take ln of -2 on your calculator, you'll get an error. So they normally use absolute value symbols as a way of telling you that you must choose an x value in the positive region. Of course, you also cannot choose 0. You can't take ln of 0, and that makes perfect sense because you can't divide by 0 either. But by bringing this 2 back inside the ln, I don't need absolute value symbols anymore, right? Don't you agree with me that x squared will never be negative, right? Negative 2 squared will end up being a positive 4, so I don't need absolute value symbols anymore for that problem. All right, let's go ahead and continue here. So now we were trying to integrate 1 over 4x minus 1. And the game, you have to understand this, is the game you're trying to play is, is there a way of thinking about that integral as u prime over u, right? This is the game that you're trying to play. What would I have to do in order to think of that integral, that integrand, as u prime over u? Right, now that's the game. Now that's the game that we're playing. So let's try some things here. What if we let u equal, let's say, 4x minus 1? Okay. So off to the side, I'm going to go ahead and rewrite this 1 over 4x minus 1 here with respect to x. So I could use that u substitution if I let u equal 4x minus 1. Let's go ahead and look at what du would look like. Okay, remember, if you have forgotten, this is right out of integration by substitution, right out of chapter 4. And remember, this is du dx, right? So I'm just going to bring the dx to the other side in just a second. So, well, if you take the derivative of u with respect to x, we just get 4. The only difference is I'm going to, using this Leibniz notation here, I'm going to just bring that dx over here. So du is going to be equal to 4 dx. Okay. Now, so let's see what we need here. So let's start with the fact that you have defined u to be 4x minus 1, and let's go ahead and put that into practice here. So I'm going to substitute a u. I have a 4x minus 1 here, so I can substitute a u into that denominator. But that doesn't quite help me because I still have a dx to deal with. So I can't integrate that guy yet. So hold on, now let's go ahead and look at du. All right, because what I want is I want to insert a du for that dx, but let's look at our definition. And in order to substitute, I need du. I need to have a 4, and I need to have a dx. Now, I have the dx, but let's you and I agree that I'm missing the 4. All right, well, you remember how to do this. I'm going to kind of scoot this over just a little bit. You remember how to do this. If you're missing the 4, not a problem. I can multiply by 4 as long as I'm willing to divide by 4 at the same time, right? 4 divided by 4 is 1. So I've not committed any sin here. But the good news is, with this little bit of mathematical manipulation, is this 4 and this dx can now be exchanged for a du. So we get 1/4 integral of 1 over u, and now that 4 and that dx disappear, and the du appears. Almost done. All we have to do is integrate this guy. So you recall, if you integrate 1 over u, you just get ln of u. So this becomes 1/4 ln of u. Don't forget your plus c, because that would be a sin. And last, let's go ahead and take this 4x minus 1 and put it back in there for u, okay? Because your client understands x, but your client does not understand what the heck a u is. Done. Okay. You could always take the derivative of that if you wanted to check your work, right? So the derivative, that would be 1/4 u prime over u, and that would end up being, once you run those numbers, you would end up getting what we started with here. Okay, so let's go ahead and think about how you would find the area. So let's read and let's make sure we understand. So it asks us to find the area. And what are we finding the area of? Well, we're going to find the area of y equals x over x squared plus 1. Now, find the area of the region bounded, right? We got to bound our region for now. And by the graph of, well, it needs to be bounded by this, as well as the x-axis, as well as the line x equals 3. Let's make sure you understand that. So here is the line x equals 3. Here is, I don't know, see if I can get it in here. Here's the x-axis. And of course that green curve is your graph. So do you see how you can bound everything within that region, and then you can find the area of this. Okay? So let's go ahead and write that. So this is the line x equals 3. And of course we have the x-axis. And then we're looking for the area bounded by all that. All right. So as soon as you think area, as soon as you read area, you should be thinking definite integration. All right, so we need something here. We're going to need something here. Now you're going to integrate. Remember, the area, it's always the area under the derivative. So in this case, the x over x squared plus 1 is the derivative. All right, now I mentioned this in a previous videos, but to mention it one more time, if you are integrating with respect to x, then your lower and upper bound should also be x values. I'll say that one more time. Ready? If this is a dx, then what goes here should be of x, and what should go here should be an x, at x values on the x-axis. All right, looking at that graph, it looks like we start here at 0 and we stop here at 3, right? So we want x values to go from 0 to 3. All right. Now I'm going to go ahead and go through this integration process with you. So at this stage you would, right, because you're still trying to integrate from 0 to 3 of x over x squared plus 1 with respect to x. Right now, the game you should be thinking is, hey, can I write that as a u prime over u? All right, well, let's find out. So we let u equal x squared plus 1, then du would equal 2x dx. Okay, let's go ahead and start some substituting. So this would end up being the integral from 0 to 3 of, well, hold on here. We have x over, and now we had an x squared plus 1 in that denominator, but now that's going to be a u. Okay, so you know the game. I want to have a du here, and let's see what I need to do that. Well, I would need a dx. Well, I have a dx. I would need an x. I have an x. and I would need a 2. I don't have that 2. So I would have to multiply by 2 and divide by 2. All right, let's go ahead and do that. So I would have to multiply it by 2, divide by 2, and all that, so I can finally get to my my integral. All right, now you with me that this x and that dx along with that 2 is going to become du. All right, so we would have 1 here, and then we would have du here. Okay, so let's go ahead and integrate. So that would be 1/2 ln of, I'm going to go ahead and put x squared plus 1 back in, right? This is u. I got to put that back into x squared plus 1 form. So you go ahead and do that now. X squared plus 1. And I have to, since this is definite integration, I don't need the plus c, right? Because it's going to disappear. And I need to go from 0 to 3. All right. So f of 3 minus f of 0. What does that give us? That gives us 1/2 ln of, start with 3. So ln of, well, 3, right, plugging 3 in. 3 squared is 9. 3 squared is 9, and 9 plus 1 is 10. So ln of 10 minus ln of, well, let's plug a 0 in. So 0 squared is 0, and 0 plus 1 is 1. ln of 1. Okay, let's simplify that. Let's clean up our mess. So ln of 1, right here, ln of 1 is 0. So what you're left with is just 1/2 ln of 10. That is your area under that curve. Anything other than that, unless you rewrite it in a different way, but anything other than this is incorrect. So don't do this. Don't give me approximately 1.151, right? That might be great for your science and engineering classes, right? Because there you'll know what margin of error you're willing to accept, right? Maybe as long as you're within 1,000th of an inch, maybe that's okay for your application. But I didn't give you a margin of error, so let's not accept any margin of error. This is your answer. All right, got it. We got to get out of the habit of rounding answers. You don't round until somebody tells you what they're willing to accept in their rounding. All right. Now, here's a few. I'm not going to go through these examples. What I'm going to do is give you the answers. And what you should do is on your own time, you can pause the video, but you should go through and make sure you can do these. This would be ln of x cubed plus x plus c. I will tell you for part B, since we haven't done a lot of trigonometric problems yet, you would let u equal tan of x. Then what? Well, then du would equal if you take the derivative of tangent, it's secant squared dx, right? So that would be the substitution process. But let's go ahead and get you to the answer. The answer is ln of tan of x plus c. And finally, here this would end up being 1/2 ln of x squared plus 2x plus c. And the answer here would be 1/3 ln of 3x plus 2 plus c. All right, so now if you just are the type of person that just thinks that, in mathematics, I just watch my professor do it, and then all of a sudden I just can produce these answers on the tests. I hope that works out for you, but I promise you in the end, this subject, this unforgiving science, will tap you out in the end, because you don't get to watch people play the piano on videos and then YouTube videos for hours and then all of a sudden start playing the piano. Okay, this is a contact sport. You have to actually do math to get better at doing math. The last problem that we're going to do is a technique, a little technique that we use often enough to practice here. So the goal is just to integrate, right? And here's the problem with integration is you start off, you say, okay, well, let's let u be x squared plus 1, and you go through du, and it's just not working, right? You just keep trying things and it's not working. Well, I want you to have in your pocket that you can always rewrite this integrand, I mean. We're going to use long division or polynomial division. And this is the step, this is the part here, right? Where you can rewrite this fraction as the following. And what we do is we just go through, and I know for many, I don't know why I just used a highlighter. I know for many, we hated this long division back in elementary school. So we're really going to hate it when we're dealing with polynomials. But let's go ahead and do this. So what we have is we take x squared divides into x squared one time, and then you have 1 times x squared is x squared, then 1 times 1 is plus 1. All right. Now, normally you subtract at this point. Well, you do subtract at this point, and so let's just make sure we subtract everything. So that's going to end up being a negative minus the here, and I'm going to end up. What I'm going to do is I'm going to write a minus symbol, and then I'm going to circle it, because that tells me that the sign changed. Okay. Well, let's go ahead and at this stage you actually combine. So the x squareds cancel, the 1's cancel, you're just left with x. Okay? So listen, you don't get to leave this out. This is this remainder, right? This is just like if you give somebody, if something cost $4.90 and you give somebody a $5 bill, you want your change, right? You want your remainder, so don't leave it out. In this case, the answer is going to be 1, right? This 1 plus, don't forget about the remainder, so plus x over x squared plus 1. Now, if that is hard for you, then you need to take a second and Google polynomial division. Find a YouTube video, take 5 minutes, 10 minutes out of your day, and teach yourself polynomial division. Okay, so, but what that means for us is I can rewrite this integral. Instead of having this mess that we have in here, we can rewrite it as 1 plus x over x squared plus 1. Now, why is this a good news for us? Well, this is good news for us because we can break this up into the integral of 1 with respect to x plus the integral of x over x squared plus 1 with respect to x. Okay? And this is good news, I promise you. So let's start here. So the integral of 1 with respect to x is just x. Right? The derivative of x is 1. Now, the derivative, to take the derivative here, you would have to let u equal your x squared plus 1. Du would equal 2x dx. Let's think about what we have and what we don't have. So I can take this x squared plus 1 and put a u there. That's not a problem. But to get a du here, right, to get a du, I would need to have a dx, an x, and a 2. So I have the dx, I have the x, I don't have the 2. Right, so you know what happens. I have to multiply and divide by 2, just like I've done many times before. So that ends up being x plus, I'm going to go ahead and get us to our answer, 1/2 of ln of x squared plus 1. And why do I have to get out my red pen right here for some poor student? Because they lied to me. They told me that c is equal to 0 when it's not. They don't, or at least they don't know that. So I need to have plus c. All right, so that will conclude 5.2.